Just start that here. Okay, so we're recording now. Just want to say welcome and thank you all for taking time out of your day today. This is the first of what we hope will be maybe a recurring event where we do some kind of short little training webinars for Sugars for Windows, where we'll just try and point out a few kind of tips and tricks and things that maybe there probably would be in the help manual somewhere, but you might not find it unless you were looking for it, and just things that hopefully will help you out as you use the program and do things custom for your own needs. What we're going to talk about today, oh, and by the way, I'm Scott Carey. I'm the Chief Engineer of Applications and Customer Support for Sugars International. So I take care of basically first line of contact for anybody that has questions on how to use the software or any issues that come up, and also sales inquiries and those sorts of things. I also do all of the online training whenever a customer wants a longer, more in-depth training session. I take care of those as well. You probably got some messages from Sally Wallace as well. She's the president of the company now. She is the late Warner Weiss's daughter, and she's a very organized and talented business person. So it's been great working with her. In the absence of Warner, unfortunately, he passed away a little over a year ago. So to talk about what we're going to get into today, the idea is to show you all how the Visio Shapesheet can give you access to Sugars parameters, and then what you can do with those parameters to sort of customize some of your displays on your models, show things that you might otherwise not be able to with the very basics of Sugars. So anyway, before I go any farther, I just want to give out one last opportunity. If there's anybody that's having a hard time hearing or understanding me, or can't see my screen right now, you should see a page of a model that's titled Diffusion and Pulp Pressing. Anybody having any trouble with viewing this or hearing this? Okay, no one's commenting, so I assume that's a good thing. Just so you know, as we go through this, I'll try and stop periodically for questions. Also, if you have a question while I'm talking and you're afraid you'll forget or you don't want to speak up, there is a little chat window in GoToMeeting that you can post your question in the chat, and I'll see it pop up there, and then I can address it as I'm able to. So anyway, to go into the training and get started here, we have, like I said, a Sugars model on the screen, and I'm running Visio 2013, and this is the Beat Factory example model that comes with the Sugars installation. We're looking at the front page right now, and what I want to talk about to start with is the Visio Shapesheet and just what it is and how you get to it and all of that. The first thing to note is that in order to do most of the things that we're going to talk about today, you really want to enable the developer tab in the toolbar up here at the top of Visio, and that's done just by going into the options and customizing the ribbon. And in this this main tabs customization, there's a checkbox for developer right here. And so you just want to check that. So you turn on that developer tab, and that'll give you access to some things that we're going to get into today. And so that brings this developer tab into your toolbar up here. Once you have that, there is this option here called Show the Shapesheet. Now, what I'm going to do before I do that is I'm going to select an object. In this case, just to start with, I'm going to select an object that's just a text box. Okay, it's not a sugar shape or a connector or a flow stream, anything like that. Just a text box. And I'm going to go to show the shape sheet, and you'll notice that the drawing pane gets a lot smaller, and out comes this lower window pane here that shows a bunch of data and information. And basically what the shape sheet is for any Visio object, it provides a whole wide variety of data and information for that object. So for a simple text block like that, it's basically showing the width, the height, if there's any rotation angle. It's got the location information for where it's at on the page, protections, uh, formatting of lines, of text that may be in the object. All sorts of different information are contained in this shape sheet. And that's how Visio keeps track of what each object within a drawing looks like and how it behaves and all the rest. So there's lots of things there. I'm going to close this now, but like I said, this is not a Sugars object. This is just a regular Visio object. And so every Visio box, text box, shape, everything has a shape sheet associated with it that contains all that data. Now, what's more interesting to us is the Sugars data that's contained in the shape sheet. So now I'm selecting, let me zoom in so we can see this a little better. I'm selecting a flow stream, okay? This is the cassettes coming into the mixer, basically the beats feeding the beat factory. So if I select this connector, I come back up here, I can select Show Shape Sheet from this Developer tab like I did earlier, or the other way to get to it is with a right click. It's in the right click menu right here, Show Shape Sheet. And that's maybe a little bit faster, not much different. So it has some of those similar parameters that any other Visio object has, but then you'll notice that there's a list of parameters called shape data. These parameters are basically inserted by Sugars every time that you add a flow stream connector or a Sugars station shape to a Sugars model drawing. And in the instance of a flow stream, it's a pretty long list. So you can see it starts with, and the format is prop, standing for property, followed by the properties label. So in this case, it's prop.name. So the name of the flow stream. And in this case, basically it's just telling us that it's a Sugars custom property. And then we go to the pressure and the value. So these values are the actual values of the parameters for that stream. So in this case, it's 101.4 kPa is the pressure. And that guard is just a formatting thing that Visio uses around the value. And you can see that the flow rate is almost exactly 250,000 kilograms per hour. It's 75.2% water. So you can go through all of the same parameters that we can access here, and I'll come here and we can. So if we open the flow, the Sugars properties window, these are the same parameters that we're seeing in that shape sheet. Okay. And you can scroll down and go through all the parameters associated with that flow stream, all the way down to things having to do with massequit and saturation temperature. I mean, everything that's associated with it is here. Okay, and the same thing is true. I'm going to go ahead and close this shape sheet for this flow stream. Oh, one more thing before I close it. At the top of the shape sheet is the identifying name of that flow. So because it's an external flow, comes in from outside the model, it says its name is to station 130, port 0. This station right here is station 130. It's coming into port 0. So that's how it's identified, because it's an external flow stream. If we chose an internal flow stream, it's a little bit different. So here's one right here. I'm going to close this shape sheet, and we're going to look at one for this internal flow. For internal flows, the identifier is what station it comes from. So in this case, this internal flow is coming from station 172, port 1, and that's how it's identified right here at the top of the Shapesheet window. That's important. You're going to want to remember that later because we'll use that to reference some Shapesheet parameters. And I'll remind you, don't worry. Okay, and the other thing I wanted to show you was for Sugars stations within Visio. If we show a Shapesheet for that, okay, so this is station 175. It's a heat exchanger, so it has a set of shape data properties. You notice these are different than the connector properties were. We're looking at things like the outlet temperature, the temperature rise, heat transfer coefficient, effectiveness. Okay, those are all specific to a heat exchanger station. If we were to choose a different type of station, let's choose a pump, you'll notice the pump it's a shorter list, but it has a different set of shape data cells within the shape sheet. So what you end up finding is that all the different Sugars stations have a different list of shape data properties in the shape sheet. Okay? All right, so before I move on, anybody have any questions? Let me open up the little window here so I can see them. Anybody have any questions about how to find the shape sheet and what's in the shape sheet? Okay, all's quiet. Can anybody still hear me? Let me get one response to make sure we still have everyone.
Yes, Scott, we can definitely hear you. It's all good.
Okay, excellent. Thank you. And I have a message here that says yes. All right. Very good. I appreciate that. Okay, so the next thing I want to talk about is what can we do with this shape sheet information? How does it help us when we're making models? So I'm going to move in this example model over to the page for evaporation. And so now we're zoomed in a little bit. We're looking at the front end of the evaporator train for this beet factory model. And the first effect is right here at station 710. So if we open up the Sugars properties for an evaporator, we have the heating surface area, we have pressure, temperature. You can click on the heat transfer coefficient calculator will show up here, and you can calculate the heat transfer coefficient for different surface areas. And all of that's interesting information, but as soon as I close this dialog box, it's gone. We can't see it on the drawing. And there's no way to easily just right click. I mean, for a flow stream, I can add a flow legend, and I can add a bunch of information to the screen, to the display of Sugars parameters, okay? But for a station, there is no flow legend. If I right click, you notice there's no legend, no way to display anything from the station in its properties. But there is, okay, and that's where the shape sheet comes in, and that's what I'm going to show you how to do, okay? So if I wanted to, for instance, let me open that back up. If I wanted to display the heating surface area of this evaporator on the drawing, I can do that. And why is that useful? Well, let's say I was a process engineer and I was developing a process flow design with Sugars, and then everyone agreed the process was good, and we wanted to send it over to the mechanical designers for them to do the detailed mechanical design. Well, they need to know how much surface area each evaporator needs to have. And so to have that on the drawing, if you print it or if you print it as a PDF file and it's just a display, it's very informational for them to have that. So how do we get that on the screen? All right, so what I'm going to do is I'm going to start by just going to insert, and I'm just going to insert a regular old-fashioned text box. Okay. And just for a placeholder, type the word text so we can see it. Okay. So here we have a text box, and I can type in here heating surface. Okay, that's what I want to know. Now, here's where we can go to the Insert menu, and this is what you're looking for. Is this? It's called Field. Okay, so if we click Insert a Field, Visio brings up a dialog box here, and there's some different things we can do. But what we're going to do is come to Custom Formula, and here we can type in a reference to a Shapesheet property. Okay, so before we do that, though, we need to know some things about what we're looking for. So here's where we're going to put it in, but I'm going to back out for a second. Okay, cancel out of that. I want to come to this this evaporator, station 710, and I'm going to show the Shapesheet. Okay, so like the other stations we saw earlier, its identifier is station 710. That's easy enough. And we want to know what property the heating surface is. Okay, well, here it is. It's prop.heatingSurface. Okay, so we need to remember that station 710 and prop.heatingSurface, because that's how we're going to refer to this. So we can actually leave that on the screen. There we go. Okay, I want to insert my field. Custom formula equals. Okay, so here's the syntax. Here's how this goes. We want to reference the station, station 710, followed by an exclamation point. Now we're going to type in the property. And Visio is nice because it gives us the list of properties that we have to choose from. I went ahead and typed it, but I could have clicked it right here and it would have filled in. Okay, so I'll hit enter. And look, all of a sudden, I didn't type 1200. 1200 was filled in because within that custom formula field, we referenced this Shapesheet parameter. Okay, now 1200 is correct, and that's the number that we were trying to display, but let's say we want it to be a little bit better formatted. Now that it's a field, now that I have the field here, and I right click on it, I can go back to Insert Field, and Visio is a little odd because I have to reselect what I want there, but I can go to Data Format here, and I have a whole list of choices of data formats. In this case, it's just a number. I don't want any decimal places. We can round off to the nearest or square meter. And I do want the thousands separator in this case, just because that'll look nicer. Click OK, click OK. Now I have the format for the data. Okay, and then I can type the units here, square meters. And within Visio, I can even come and make that superscript. Okay, so now we're displaying the heating surface area in square meters. Let's also display another parameter. How about heat transfer coefficient? We can do that within the same text box. Okay, we see here that in the shape sheet it's called prop.heatTransferCoef. So here I'm going to come back, I'm going to insert a field again, custom formula. Now you'll notice that we have the option of using the previous custom formula. It remembers that in case we want to reuse it. But of course this time we don't. We're going to use a different one. station 710, exclamation point, crop dot heat, and I'm just going to click it this time to make it easy. Heat transfer coefficient. And the data format, number, and again, I'm going to do the same format. Click OK. And there's our heat transfer coefficient displayed right on the drawing. And I could do that for all the evaporators, and that way, when the designer is looking at this sugars model, they don't have to be running sugars. They can have either a printed copy or just an image file, a PDF, or however you want to save it. And they can see that data right on the screen. And you can do that with anything that is in this Shapesheet shape data list. Okay? All right, so that's interesting. But what if we want to do more than just display parameters? What if we want to do some sort of custom calculation? All right, so I'm going to close this Shapesheet. Hang on, before I move on, I'm going to check for questions here. Okay, someone would like me to zoom in a little bit. Okay. And okay, I think everyone, don't see any other questions on our chat list here, so we will keep going. So custom calculation. For instance, sometimes in an evaporator train, it's interesting to talk about the evaporator economy. Okay, so evaporator economy is simply the amount of water evaporated from the juice divided by the amount of live steam that comes into the first effect. Okay, and usually that number, it can vary widely. It can be anywhere from about 2.0 to about 5.0, depending on how many stages of evaporation you have and how many vapor draws you have and all the rest. So in order to calculate it, all we really need to do is subtract the mass of the juice out of the evaporator train. This is coming out of the last effect. This is the thick juice. Subtract the mass of the juice out from the mass of the juice in. This is coming from the thin juice heater to the first effect. That difference is the water that's evaporated. That's the only thing that we take out of the juice in evaporation. And then we divide that difference by the mass of the steam input to the first effect. And that's a calculation of evaporator economy. So I'm going to come up toward the top of the page here, and I'm going to add a text box, just like we did before. Oh, I think I missed. Try again. I'm going to make it pretty big. Placeholder there. And we're going to make the font of this a lot bigger so you can see it. Okay. So this will be our evap economy. Okay. Now I'm going to have to zoom out a little bit here just so we can see overall what we're working with. Let's see. Slide over. There we go. Okay. So we have several flow streams that we need parameters off of in order to do this. Okay. So for the thick juice out, I'm going to show the shape sheet. Okay. This flow stream is identified as from 750_0, and this BEG stands for beginning. And the reason that shows up there is because this flow stream is a cross page, or it's a flow stream. It's using a cross page connector. So this leaves this page and goes to another page where it connects again, and that would be the same identifier, except for it would use end instead of BEG for beginning. So that's why that BEG is there. All right, and the property that we're going to be looking for is simply the flow rate in kilograms per hour. So prop.flow rate. Okay, and I've got it on my other screen here. I'll show you just for a second. I have notes. I did these notes earlier, but if I'm working on a model, and I'm doing a calculation like this, I'll start typing the formula on some notes using the flow stream identifiers and the properties that I need so that I don't forget them. Okay, so in this case, we're subtracting this thick juice out from 750_0 beginning prop.flow rate. So I'd type that there because I need to look at the flow legend for the juice in. Oops, I'm sorry. Shape sheet, not flow legend. There's the shape sheet. So this is flow from station 706_0. And again, we're looking for prop.flow rate. So in my notes, that's here. That's the input flow, and we're going to subtract the output flow, and this quantity right here will be the amount of water evaporated from the juice. It's the difference between the input and output juice flow quantities. Okay. Now we need to know the parameter from the shape sheet for the steam flow, and we're talking about the live steam coming to the first effect. So we'll show the shape sheet. This flow is called from station 950_1, and you'll notice it has the end identifier on it because it's the end section of a cross-page connector. And again, the prop is just flow rate in kilograms per hour. So it's nice that the units are the same for mass flow on all these connectors. So when we're doing a ratio like this, we don't have to do any unit conversions. Okay, so in my notes, I'm dividing by that steam flow, which is this from 950_1 end, and the prop is flow rate. Okay, so now in our text box here, I'm going to come over to where I want it, and I'm going to insert a field. It's a custom formula, and since I already typed this formula in my notes, I'm going to copy it and then I'm going to paste it. I'm just going to use Control V, keyboard shortcut Control V. We'll paste that in there. And the data format for this one will be a little different because this is a small number. So we probably do want to keep 2 decimal places, and we don't need a thousands separator because it's not going to be that large. And if I click OK, all of a sudden here we show the evaporator economy for this train of evaporators. So that shows you how to do a custom calculation using Sugars parameters from the shape sheet to display some sort of key operating parameter or key performance indicator that you want to show in your Sugars model. And that's really useful because that way you don't have to go back every time you rebalance the model and find those flows and recalculate it separately. Every time you balance the model, if you make changes, this calculation will be updated and the display will update right along with it. So very useful information. Okay, so there's one more thing that I want to talk about briefly here. And this is, what if I want to do one of these custom calculations, but the parameters that I want to use come from flow streams or stations that are not on the same page of the model, okay? And this is a very, I want to call it a little bit of a backhanded trick that Visio has done to us. It requires us to do something a little different that's kind of tricky. So in this case, we're going to calculate a parameter that most beat factory operators call steam on beats. Pretty simple. We're just going to calculate how much steam is used per the amount of beats that comes into the factory. Okay, so I'm going to come over here to the steam and water page because I want to display the steam on beats on the same page with the boiler. Okay, and I'm going to insert a text box just like we have been. Okay, and we're going to make it larger font again. Let's go ahead and type this. Steam on beats. Okay. So what do we need to know in order to calculate the steam on beats? Well, we need to know how much steam is coming in to the factory, and so we're just going to go to the boiler output steam flow here and show the shape sheet. And just like before, we have the identifier is from station 970 port 0 and prop.flow rate. Okay, same as any other flow stream where we want to know the flow. All right. Now, if we want to compare the amount of steam to the amount of beats that we're processing, we have to go over to the diffusion page to look at the cassette flow. Okay. So, oh, and by the way, a minute ago in my notes, I would put in that I got the steam flow prop.flow rate. Okay. So I'm typing up my formula in my notes as I go. And so on this beat cassette flow, if I show the shape sheet, I think I showed this one at the beginning. This is 2 station 130 port 0, and the property that we need is the flow rate. And again, it's all in the same units, so everything compares easily. But here's the trick, okay? Here's the part that you gotta pay attention to. When you're doing a cross-page reference in a custom formula in Visio, you can't simply use the, here, let me go back in there one more time. You can't simply use this identifier, this 2130 port 0 identifier. I don't know exactly why. You should be able to look at the page and then the identifier, but Visio works a little differently. If it's a cross-page reference, go ahead and maximize that again. We have to do something. We have to come up to the developer tab, and that's earlier part of why I said we should make sure the developer tab is available. And we come to this little option right here under shape design called shape name. Okay. When you click the shape name, Visio displays a few things about the shape, but what we're looking for is this ID number. Every connector and every shape has a unique ID number, and the only way that I know of to view it is to select the shape, come to developer and click shape name, and it shows right here in this shape name window the ID number. So in my notes, as I'm typing this formula, I've got the steam flow already. Now I'm going to divide by the beat flow. Okay, it's pages, and in brackets, braces, you write the page name, which is 1-diffusion. That's right here. Okay, exclamation point, and then because it's a connector, the identifier is dynamic connector with a point, and that ID number, that 83, comes from right here. And then another exclamation point, and just like every other one, it's prop.flow rate in this case. All right, that's the tricky part, and that's the part you're going to want to remember. All right, so I'm going to clear or get out of this little dialog box. I'm going to go back to my steam and water page, and I'm going to insert a field. It's a custom formula. And again, this time, since I've already typed it up, I'm going to copy it. And I'm going to paste it. Okay, and then this one's going to come out as a fraction. Steam on beats will be some fraction. Usually it's somewhere in the neighborhood of anywhere from 15% to 40%, depending on the factory. But I'd like to show it as a percentage. So in my data format, I can show it as a percentage. Let's keep one decimal place. Click OK. And so it just happens that this factory's steam on beats ratio is 35.2%. And again, if we change the model, if we make updates, we rebalance, this will automatically recalculate and the display will automatically update. Okay, and so that's the, like I said, the trickiest part is finding that that ID. And I'm going to do it again just so everybody remember or can see it. This time we're going to do a cross-page reference to a station parameter. And this doesn't have a lot of meaning. This is just an example. I'm going to say heat X effectiveness. Okay, so we're going to go back to that same diffusion page, and we're going to look at heat exchanger. This is a circulation juice heat exchanger. And if I go to the shape sheet for that heat exchanger, my shape sheet got out of position. There we go. This is station 175, which we can see on the drawing, station 175. And the effectiveness of a heat exchanger is prop.effectiveness. Pretty simple, in percent. Okay, but again, I'm going to reference this from another page, so I can't use this station 175 identifier. I have to come to developer, shape name. Okay, this shape's ID is the number 13. So in my notes, I'm going to type the formula to reference this shape. It's pages 1-diffusion in the braces, exclamation point. The type is a heat exchanger, and its period ID is 13. That came from this shape name dialog, exclamation point, and the prop effectiveness again. Okay, so I'm going to go ahead and copy that while we're here. Edit, copy. And I'll cancel that. Close the shape sheet. Maximize. Come back to the steam and water page and insert a field, custom formula, and Control V to paste. The effectiveness, I believe it's already in percent in sugars, so we'll just make it a number. Don't need any decimal places. Yeah, so that heat exchanger's effectiveness was 97%. We could type a percentage there just so it displays the units correctly. So now you can see how to reference shape sheet data both on the same page and across different pages, and you can do it just to display parameters or to do custom calculations that display on the drawing. So that's about all I have. I know in the original invite this training session had an hour and a half listed, but I really didn't plan on taking up that much of your time. Before we wrap up, are there any other questions or comments about what you've seen here? I'm looking at the chat window here. If anyone has anything, you can type it in, or you can just unmute yourself and speak up. Okay, looks like all's quiet, so I'll take it to mean that everybody has already got this all figured out, and they've already been adding it to their models right on their screen, maybe. But in any case, I'll go ahead and wrap this up, and I just want to say thanks to everybody for. Oh, we have a question. Hang on just a second. Where do the yellow sugar objects come from? Okay, so this is a question asking, I believe, how to add shapes from the sugar stencil. So I'm just going to show the document stencil on this drawing here right now. So in this case, I'm showing all the shapes that are already on this drawing. You can also go and open the Sugars stencil, which would be in your Sugars installation. See program files x86, Sugars stencils. There's a whole list of them here. So for instance, if I wanted to open the evaporator stencil, I could do that. And now the evaporation shapes show up here. And so then all these shapes from that Sugars stencil are Sugars station shapes. And if I want to add one to the drawing, I just drag it and drop it. And of course, it has to have a station number. And this is starting to get into more general Sugars operation. But I could give it number 1100. And now it's blue right now because it doesn't have a name. If I name it, oops, flash 1, now it turns yellow. So that's where the stations come from, is this the stencil over here with all of the sugar station shapes. Okay, I have another question. Okay, the question asks, will you show your calculation sheet that you copied from so that I can screen capture the formats that you used? Absolutely. Here we go. And you know what? If you guys would like, we could probably even email out this little note sheet here, because not only does it have the syntax for the formulas, I also put up here how to find that silly Shapesheet ID that you have to have for cross-page references. So in Visio 2013, you go to Developer, Shape Name, and the top item is the ID number. So yeah, go ahead and copy this now if you want, or like I said, we can actually send out this. And yes, this next question, will we send out the webinar recording? Absolutely. I've been recording it the whole time. So what we're going to do is, I believe, GoToMeeting will create a link, and we'll email out the link of the recording to everybody. Okay, looks like Fikadu is asking when we plan to, I'm assuming it means do a little training session on exporting data to Excel. That's a good suggestion. And one of the things I was going to say as we wrap up here is that we'll probably do these little training sessions something like maybe quarterly. Not sure exactly yet how often we'll do them. But what I would appreciate very much is suggestions on what you guys are interested in learning about. And so exporting data to an Excel sheet is a great topic that we could cover in the next one. So I'll make a note of that. I appreciate that, Fikadu. And if anyone else has any other suggestions, you can either tell me now or feel free to email us at any time. If you use that Sugars at Sugars Online, that goes to Sally, and then she usually forwards them on to me. And also my email address directly. Some of you have that. It's just skahere@sugarsonline.com. And one more question I see here, could you use Excel to import data? So that is a little bit more complicated operation to do. There is a way to do it if you have the XML import-export data functionality, which is kind of an add-on to Sugars. And again, that's another, probably a topic for another training day. But I appreciate you bringing that up. So anyway, any more questions or comments before we finish up today? Okay, well, again, thank you very much. We all appreciate you guys being Sugars partners. And like I say, anything else that you need, any questions that come up, don't hesitate to give us a call or an email. Email works best typically. and we'll get back to you as soon as we can, and hope to see you on the next Sugars training. Thanks a lot. Have a good day, everybody.